next lab you will be completing in this class is the Analysis of an Unknown Salt, Part 4. In Parts 1 through 3 of this lab, you gathered experimental results for the melting point, flame color, hygroscopy, percent water, and density of your unknown salt. During Part 4, you will be determining the heat of solution of your unknown salt, using a coffee cup calorimeter to allow you to better determine the identity of your unknown salt. Heat of solution is the heat that is absorbed or released when a salt is dissolved in water to form a solution. If a salt releases heat when it's dissolved, it has a negative heat of solution. If a salt absorbs heat, it has a positive heat of solution. The coffee cup calorimeters we'll be using in this lab have two coffee cups stacked on top of each other, and the bottom of another coffee cup that has been cut and holes have been placed in the lid. These have already been constructed for you. Before you begin your experiment, make sure your coffee cup has been well cleaned with deionized water and then dried thoroughly using a paper towel. Because coffee cups are a little unstable on their own, you should place your coffee cup calorimeter into a beaker to give it some weight and give it stability. In this lab, you'll be measuring the temperature change of water when you dissolve your salt into it. The thermometers we'll be using today are called alcohol thermometers, and they measure to the 100th place in degrees Celsius. These will be provided for you on the lab cart. Do not use the thermometer in your lab drawer, as it only measures to the 10th degree Celsius. In addition to a beaker to make your setup more stable, you will need a ring stand with a support ring. This support ring will hold the thermometer in your coffee cup calorimeter and will also hold your metal stirring rod. The metal stirring rod goes into the small hole in the top of your coffee cup calorimeter. The thermometer will then go into the ring clamp. To start your experiment, you're going to put on your safety goggles, and then you will measure 50 milliliters of deionized water using a graduated cylinder. You'll then add the water to your coffee cup calorimeter and measure the initial temperature of the water. Record it in your data table. You'll then use a weigh boat to weigh approximately 5 grams of your unknown salt, and you'll be ready to begin your experiment. You'll double check your initial temperature, make sure it still matches what is in your table, and then you will carefully and quickly add your salt to the coffee cup calorimeter, put the cap back on, and then dissolve your salt. You can do it in one of two ways. You can either turn this stir rod, or you can gently swirl your coffee cup, making sure not to splash any water up on the sides of the coffee cup calorimeter. You'll then watch the temperature change, either go up or down. Make a note of the temperature and how it changes in your qualitative observations, and record the final temperature that your water reaches in your data table. After the temperature has stopped changing, look inside of your coffee cup calorimeter and see if all of your salt has dissolved. If it is not dissolved, or you did not see a temperature change between 1 and 2 degrees Celsius, you might need to make modifications to your experimental procedures. If all of your salt did not dissolve in your coffee cup calorimeter, in your next trials, use less salt. If the temperature did not change significantly, meaning it did not go up or down 1 or 2 degrees Celsius, use more salt for your next trials. And now I'm going to show you the data table you will need to bring to lab with you, and the calculations that you'll use to calculate heat of solution. There is only one data table for this lab, and as you see on the top, it has a table number and a table title, as all tables should have. There's then a description of all the measurements I'll be making and the units associated with those measurements. There's also space for 1, 2, 3 trials in this experiment. You'll notice that some of the descriptions are in a different color font. That is because the orange ones are the measurements that are done in lab. You'll measure the volume of your water in milliliters using your graduated cylinder. Using the initial temperature of your water, you'll then find the density of the water using the table located in lab. You'll also measure the mass of your salt in grams and the initial and the final temperatures of the water. The black measurements, or descriptions, or actually that are calculations that are done after lab has been completed. There are quite a few calculations that are associated with this lab, but you were given 3 mathematical equations to start with. You know that heat is equal to mass times the specific heat capacity times the change in temperature. We're going to define these variables for the water. So heat of water is equal to the mass of water times the specific heat capacity of water times the change in temperature the water undergoes. We also know that any heat that is absorbed or released by the water by the salt is absorbed or released by the water. So if you know the heat of salt or the heat of water, you can calculate the other one just by changing the sign. Any heat that is absorbed by the salt was released by the water, and vice versa. Heat of solution is the heat of salt in kilocalories divided by the moles of salt that were used. Your first calculation will be to determine the heat of water. It was either absorbed or released when your salt was dissolved. Heat of water is equal to the mass of the water times the specific heat capacity of water times the change in temperature of the water. The mass of the water can be determined by multiplying the volume of the water in milliliters by the density of the water as determined by the initial temperature of the water. The specific heat capacity of water is 1.00 calories per gram degree Celsius. And the change in temperature is the final temperature minus the initial temperature. Once you have calculated all 3, mass, specific heat capacity, and change in temperature, you'll then be able to calculate the heat the water either absorbed or released when your salt was dissolved. Second, you'll now need to find the heat that was released or absorbed by the salt. To do that, all you do is take the heat of the water and change the sign. So if the heat of water was negative, the heat of salt is positive. If the heat of water was positive, then the heat of salt is negative. The third calculation you'll need to do is to determine the moles of salt that you used in your experiment. You measured the mass of the salt in grams. And to determine moles of salt, just take the mass of your salt and divide it by the molar mass of the salt you think you have. This means that to do this calculation, you'll need to make a prediction about what the identity of your salt is in order to calculate the molar mass. If you have 2 possibilities for your unknown salt, you'll need to do these set of calculations twice, one for each of the different molar masses. You're now ready to find heat of solution of your salt. In the second calculation, this calculation you'll need to do will be heat of solution is equal to the heat of your salt in kilocalories divided by the moles of salt that was used. In the second calculation, you found the heat of your salt. And in the third calculation, you found out how many moles there were from the mass that you measured in the lab. When you calculate heat of salt initially, it will be measured in calories. You'll need to convert it into kilocalories by dividing by 1,000, since there are 1,000 calories in every 1 kilocalorie. Once you have converted heat of salt into kilocalories, you can then divide it by the moles of salt that were used. This will give you heat of solution units of kilocalories per mole. As in all labs, before you leave, you should dispose of all of your chemical waste into the designated containers in the fume hood. When you have finished the experiment, you should return any borrowed items to the cart or drawer where you found them, wipe off your lab bench, and when your lab bench is clean, you may remove your goggles, lock your drawer, and wash your hands. I highly recommend for this lab, before you leave, you complete all of the calculations as I have outlined them on this